Problems that use analytical method and or graphing utility. I'm gonna target only analytical method, okay? Identify the graphical asymptotes. Asymptotes, it's either vertical asymptote or the horizontal asymptote. For this section, we pretty much like work on the vertical asymptote. Um, And if you have the graph or the graphing calculator, you can always get all of them. But I'm gonna be focused on the analytical method. Okay. For this problem, this is the rational function. Okay. Before I get to the thing about the vertical asymptote, could you help me factor completely the numerator and denominator? Anyone?
The numerator would
Mm-hmm.
be x minus 2, x minus 1.
X minus 2 and x minus 1. Thank you. How about denominator?
X squared times 1 minus x. Yep. X minus 1.
Let me see. Someone, Jeff, is that you? Okay. Could you say it again, please? The microphone is kind of not quite loud enough.
Said it's x squared
X squared
times
times
the
1.
quantity of
Thank you.
x minus 1.
All right. After you factor completely, before we do anything after this, could you tell me what is the domain of this function? What would be the domain? And again, feel free to type in the chat if you prefer to do that way. X not equal to 0. Okay, and also this one, X cannot be 1, right? X cannot be, because the denominator, you have to prevent X from being 0 or being 1. Otherwise, you get undefined. So that is domain. That's from chapter 1, right? Chapter 1, the what we did. Why I list as domain? Because I'm going to show you the domain and the vertical asymptote. They are related, but not always the same thing. Not always the same thing. So back to the factoring form of this function. You guys help me out already. So we can see x minus 1 can be reduced, correct? Can be reduced. Therefore, the function can be rewritten as x minus 2 divided by x squared, as long as x cannot be 0 and 1. Because we're going to keep the domain, to keep an eye on the domain. The function can be simplified, but we have to think about what numbers that we cannot use as an input. Right. So from the earlier concept, earlier part of the 2.4, 2.4 is about the infinite limits, which gives you what the vertical asymptote at x equals a, vertical asymptote. What do you think? What do you think that could be the vertical asymptote for this function? You can type in the chat if you like. What do you think the possible vertical asymptote for this function? The asymptote means the x approaches that number where y approaches either infinity or negative infinity. All right. No response. All right. So to find the asymptote for this section, look at the vertical asymptote. We know that the vertical asymptote can be found by finding the limit of the function as x approaches a would be either positive infinity or negative infinity. That's pretty much the recap for this section. Okay, 2.4. To have the infinite limit and x equals a, gonna be your vertical asymptote. And when you have the function as x minus 2 divided by x squared, we know that the bottom cannot be 0. That's the target. So we're gonna take the limit to show that we claim x equals 0 as a vertical asymptote for this case. So we check it by finding the limit as x approaches 0 of x minus 2 over x squared. What do you think? You do the direct substitution? You cannot do that. But the top, it will remain as negative 2 because you can think about x as a 0 versus 0 gonna be that small number as well. So 0 minus 2 is negative 2 divided by, now if we look at the number 0, you could have done like approaching 0 negative, approaching 0 positive. The thing is, the denominator is in terms of x squared. When you square it doesn't matter the quantity is negative or positive inside. The result going to be positive no matter what. Do you guys agree? Yes? Okay.
Yes.
Positive? Yeah.
Yeah, I was agreeing.
Okay, thank you. So that's another thing that will help you save your time when you look around as a whole thing, as a whole picture of the problem. X squared gonna make everything positive. And since x approaches 0, the number that comes in gonna be small no matter what, positive sign, negative sign. When you square, become positive inside. And then negative 2 divided by small number gonna be negative infinity. So this is a confirmation that x equals 0 is your vertical asymptote. Okay. How about at 1? Is 1 the vertical asymptote? From the concept over here, the vertical asymptote, when the limit equals either negative or positive infinity, we're going to check, okay, if you take the limit as x approaches 1 of the function we can use the simplified form. Okay, what do we get? We will do the direct substitution for the denominator. That's nice. The denominator is not 0. That means you're going to get some real number out as the limit value. So 1 minus 2 on the top becomes negative 1. Well, negative 1 is not positive or negative infinity. So therefore, x equals 1 is not a vertical asymptote. Okay, x equals 1 not, but x equals 0, yes. And the reason that I list the domain before we looked at the vertical asymptote, because sometimes domain and vertical asymptotes, they are just the same number. Like you would say like, oh, if I list the domain as x not 0 and x not 1, so both x equals 0 and x equals 1 would be the vertical asymptote, but not for this case. What you have here, x 0, yes, but x equals 1 gonna be the case you have a hole on the graph. You have a hole on the graph. You can find the limit, but you cannot find the function value. Okay,